Hi friends, welcome to my channel. Today I'm going to show you how to solve a problem related to analytic geometry. Okay, so this is our problem. Find the center of the circle represented by the equation 225x squared plus 225y squared minus 300x minus 360y minus 1781 equals to 0. So this is my step-by-step solution. In step 1, I wrote the equation as is. Notice that literal coefficients x squared and y squared had the same numerical coefficient, which was 225. In step 2, I used the numerical coefficient 225 as a divisor of each term of the equation. In step 3, cancellation of terms was done for x squared and y squared. The rest of the terms were not yet reduced to the lowest term because the GCDs of each fraction must be identified first. After thinking for a little while, I found that 75 was the greatest common divisor of the fraction negative 300 over 225. And 45 was the GCD of the fraction 360 over 225. In step 4, the fractions were already reduced to the lowest terms by the division of their greatest common divisors. The fraction negative 1781 over 225 remained because there were no factors to be cancelled. Okay, in step 5, although the negative 1781 over 225 could not be reduced to the lowest term, it could be transferred to the right side, making it positive 1781 over 225. The left-hand side of the equation remained the same. Okay, the equation of step 6 was long, so I decided to divide the equation into left-hand side and right-hand side. In the left-hand side, two kinds of completing the squares were applied. Let's talk about the first kind of completing the square. To find the third term of x squared minus 4 third x, the fraction 1/2 was multiplied by the numerical coefficient of x. Then the product was squared. Same procedure was done for y squared plus 8/5 y. These were all in the left-hand side. Notice that two new quantities were added in the left-hand side. These same two new quantities were added also in the right-hand side to maintain the balance of the equation. In step 7, the third terms were simplified already. Same with the right-hand side. Okay, step 8, two groupings were made in the left-hand side. The groupings was based on the kind of variable used as literal coefficient. The third term was enjoined to the group where it came from. In the right-hand side, I transformed the third terms into similar fractions so that these fractions can be added readily to the constant, which is positive 1781 over 225. Okay, in step 9, the trinomial x squared minus 4 third x plus 4 9 was expressed as x minus 2 third, this quantity raised to the power of 2, while the trinomial y squared plus 8/5 y plus 16 over 25 or 1625 was expressed as the binomial y plus 4/5, and this binomial squared equals to 9. Okay, this 9 here is the simplified right hand side from step 8. In step 10, take note that the values inside the variables hk and r were positive. That's why minus signs are okay. Take note that in the given equation, x minus h squared plus y minus k squared equals to r squared, the minus signs are preserved. So because the minus signs are preserved, it is expected that the values inside h, k, and r variables must be positive. Okay, so um, take a look at x minus 2/3 squared. Since there is a minus sign, there was a minus sign, so the value of h was positive 2/3. And take note also of the expression y plus 4/5 squared. The minus sign was already out of the picture, so it is expected that the variable k here has a negative value. That's why we have k equals to negative 4/5. Now after these 10 steps, I was able to find the center, hk, and it has a coordinates 2/3, comma, negative 4/5. So the h here is the x coordinate of the center. K here is the y coordinate of the center. So thank you for listening, friends and students.